You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we explore the physical connectors and ports that allow devices to communicate in modern computing environments. Wired interfaces are essential for stability, speed, and reliability in both personal and enterprise settings. While wireless technologies are growing in popularity, many IT functions still rely heavily on cables and physical connections for core functionality. Understanding the types, speeds, and compatibility of these interfaces is critical for technicians supporting networks, peripherals, and external hardware. This topic is covered in Domain 2 of the ITF Plus exam under Input and Output Device Interfaces. You may encounter questions that ask you to identify a port based on its appearance or function, choose the right interface for a scenario, or resolve a connectivity problem based on cable type. Matching cable types to speed requirements, identifying color-coded ports, and selecting appropriate adapters are all common exam skills that require strong familiarity with wired interface standards. A wired interface is a physical connector used to transfer data, power, or both between devices. These connections are typically more stable and less prone to interference than wireless methods. Wired interfaces are used to connect keyboards, monitors, storage devices, and networking hardware. In environments where speed and consistency are priorities, like office networks, gaming systems, or server rooms, wired connections offer unmatched performance and predictability. The most common wired interface is USB, or Universal Serial Bus. USB is used for connecting a wide variety of peripherals, including keyboards, mice, printers, scanners, external drives, webcams, and more. USB supports both data transfer and power delivery, making it highly versatile. Most operating systems support plug-and-play detection for USB devices, meaning they begin working as soon as they are plugged in. This makes USB the default connection type for most modern peripherals. USB comes in several connector types. USB-A is the standard rectangular port found on desktops and laptops. It supports devices like flash drives, mice, and keyboards. USB-B is a square-shaped connector often used for printers and external hard drives. USB-C is the latest standard, featuring a compact reversible design. It supports faster data transfer, higher power delivery, and video output in many cases. USB-C is now standard on many modern laptops, tablets, and smartphones. Different USB versions define the speed and capabilities of the connection. USB 2.0 supports speeds up to 480 megabits per second and is typically marked by black ports. USB 3.0 with blue-colored ports reaches up to 5 gigabits per second. USB 3.1 and 3.2 offer speeds up to 10 or more gigabits per second and are backward compatible. USB 4 combines multiple standards and supports Thunderbolt, making it ideal for high-speed external drives, monitors, and docking stations. Another critical interface is the RJ45 Ethernet port, used for wired networking. This port accepts CAT5E, Cat6, or CAT6A cables to connect computers to switches, routers, or other network infrastructure. It is commonly found on desktops, laptops, servers, and VoIP phones. Ethernet connections are stable and fast, making them ideal for situations where Wi-Fi interference or security risks are unacceptable. Ethernet speed classifications include 10BASET, which supports 10 megabits per second, 100 BASE-T, which supports 100 megabits per second, and 1000 BASE-T, also known as Gigabit Ethernet, which supports 1 gigabit per second. Higher standards like 10GBASET support 10 gigabits per second and require advanced cabling. Understanding which cable type and switch port matches a device's Ethernet capability is important for troubleshooting and performance optimization. The SFP, or Small Form Factor Pluggable Interface, is used in enterprise network switches and routers to enable high-speed, long-distance communication. These modules are hot-swappable and support fiber optic or copper connections, depending on the module type. SFP ports are commonly found in data centers, high-speed networks, or any environment that requires flexible and scalable networking infrastructure. Display interfaces are another critical group of wired connections. HDMI, or High Definition Multimedia Interface, is used for transmitting both video and audio from a computer to a monitor or television. DisplayPort is another high-performance connector often used in professional setups for high-resolution displays and multiple monitor configurations. Older interfaces like VGA and DV may still be found in legacy systems and require adapters for compatibility with modern hardware. Knowing which display cable to use and which adapters to apply is a daily task in IT support. There are also several specialized wired interfaces worth noting. The 3.5mm audio jack is used for headphones, microphones, and speakers. While many mobile devices have moved away from this connector, it's still widely used on desktops and older laptops. Legacy ports like PS/2 were once common for keyboards and mice, but are now rarely used except in older systems. eSATA, or external SATA, was used for connecting high-speed external storage and has largely been replaced by USB 3.0 and USB-C solutions. Cable characteristics such as shielding, material, and length have a direct impact on performance. For example, Ethernet cables longer than 100 meters may experience signal degradation unless amplified or replaced with fiber. USB cables may have limited power delivery over long distances. Using the correct cable type for the intended length and environment is essential to avoid data loss, slow speeds, or intermittent connectivity. Cable quality matters just as much as device compatibility. Adapters are essential in modern IT environments where new and old technologies must coexist. USB-C to HDMI, VGA to DVI, and Ethernet to SFP adapters allow technicians to bridge the gap between different generations of hardware. When purchasing or deploying a device, it's important to identify whether adapters are needed in advance. This avoids downtime and ensures users have access to all necessary functionality without waiting on additional parts. Proper labeling and identification of cables help prevent confusion and streamline troubleshooting. Color-coded ports, cable tags, and physical characteristics like size and shape are useful for distinguishing interfaces. For shared environments like server rooms or offices with multiple devices, labeling both ends of a cable and maintaining documentation ensures easier maintenance and support. When servicing systems, diagrams or manuals can further support cable identification and correct connection. Security is another factor to consider with wired interfaces. Physical access to a USB or Ethernet port can expose a system to unauthorized data transfer or network access. In high-security environments, unused ports may be disabled in the BIOS or blocked physically using port blockers. Network jacks in public or sensitive areas may be disconnected or monitored to prevent rogue device access. IT teams should assess risk and implement physical security measures alongside digital protections. Wired connections offer several advantages over wireless alternatives. They provide faster data transfer, lower latency, and fewer interruptions caused by interference or congestion. These traits make wired interfaces the preferred option in environments where reliability is critical, such as video editing, large file transfers, or online gaming. For enterprises, wired infrastructure also simplifies bandwidth planning and offers more control over network segmentation and quality of service. However, wired interfaces are not without their limitations. They reduce mobility and increase physical clutter, especially in environments with many devices. Planning cable routes, selecting correct lengths, and managing installation logistics require time and tools. Some devices may not include enough ports, requiring hubs, splitters, or expansion cards. Despite these challenges, wired connections remain vital for many IT setups where performance takes priority. Installing devices using wired interfaces often follows a consistent process. USB and Ethernet devices are typically plug-and-play, requiring no manual driver installation. For Ethernet, once the cable is connected, the system will request an IP address using DHCP or use a pre-assigned static address. Audio and video cables may require device selection or resolution adjustments to function correctly. Understanding this process helps technicians deliver quick, accurate installations. When troubleshooting wired connections, the first step is to check the physical layer cables, connectors, and ports. A bent pin, loose cable, or damaged sheath can prevent communication. Swapping in a known good cable or connecting the device to a different port can isolate the problem. LED indicators on network devices and port diagnostic tools within the operating system offer valuable information about link status and speed. A methodical approach helps reduce downtime and identify faults accurately. On the ITF Plus exam, you may encounter questions that present a scenario involving connecting a printer, monitor, or network device. You may be asked to match the correct port or cable type, select an appropriate adapter, or determine what is preventing communication. Questions may also cover speed capabilities or physical connector identification. Practicing these topics prepares you to respond with confidence and accuracy. In real-world IT environments, understanding wired interfaces supports nearly every aspect of technical support. From initial workstation setup to installing display hardware, connecting printers, or troubleshooting network dropouts, technicians rely on this foundational knowledge. Proficiency in identifying ports, selecting cables, and resolving interface issues ensures that systems operate reliably and users receive the performance they expect. To summarize, USB, RJ45, SFP, HDMI, and other wired interfaces provide the physical infrastructure that allows devices to communicate effectively. Technicians must recognize these interfaces, understand their capabilities and limitations, and know how to apply them in various environments. Mastering this knowledge ensures success on the ITF Plus exam and supports competent, professional service in everyday IT roles. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.